Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha. May God be pleased with her online college. Live lesson, A-level maths, year 2, pure maths. Today's topic is binomial expansion, building on from what you learned last year in year 1 of the A-level maths. This time taking a look at where the power is not just a whole number. If you're following in the textbook, it's the Edexcel Pearson textbook. It's chapter 4, example 1. Okay, Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Binomial expansion. There is a formula that you learned in year 1. So if you have something like 3 plus 2x to the power of 4, or 5, or 6, or any kind of positive power, then you can use that formula from year 1. Let me just Google it now so you can remember what it is. So here's the formula that you learned in year 1. So if you've got a plus b in brackets to the power n, and you can expand that according to this formula here. The brackets here can be found by using your Casio calculator or whichever calculator you've got, and it's called choose. N choose 1 or n choose 2. You're choosing the number of combinations from n different letters, and that will tell you what number to put in front of a to the power n minus 1b. But today's formula is going to be a bit different because that formula is only used for whole number powers. If you want to do binomial expansion with a negative power or a fractional power, then we have to learn a new formula. So today's lesson is all about something like 1 plus x to the expanding 1 plus x to the power of a negative power. And the same formula can be used for fractional powers as well, like power of a half, power of a quarter. So if you want to expand something like that, then here's how we do it. The formula starts with 1 plus x to the power of n, where n is any number. So it can work for whole numbers, but we generally use it for negative powers or fractional powers. The expansion of this, 1 plus x to the power of n, will start as 1, which is great. That's nice and easy, plus the power n times x. Again, very, very easy. And now from here it gets a little bit tricky, so you just got to keep watching and see what happens. The x is a really power 1, so I'm just going to squeeze a little power 1 in there just so that you can follow what's going on when it gets a little bit more complicated. So now we've got the next term is going to be an x to the power 2. But the question is, what comes before it? What comes before it is a fraction. On the top of the fraction, you're going to have, if you look at what I had here, I had n. So it's going to be n times n minus 1. And on the bottom of this, if you imagine there was an invisible 1, then on the bottom of this one, you're not going to quite have 2, but you're going to have something like 2 factorial. 2 factorial just means 2 times by all the numbers below it, or in this case, just 1. So 2 factorial means 2 times 1. So I'll just write that in the corner just so in case you forget. 2 factorial, which is written 2 exclamation mark, but it's pronounced factorial, really means 2 times 1, which is 2. So it's not too hard. It's quite easy. Okay, so that's the first term, second term, and that's the third term. So notice that it's quite easy to remember because this was x to the power 1, and it had 1 factorial underneath, or just 1. This is x to the power 2, and it's got 2 factorial underneath. So you can start to think that, well, what's the next one going to be? It's going to be x to the power 3. What's it going to have underneath? And then on the top, notice that it's 2 factorial. X is 2x to the power 2, and we've got two numbers being multiplied by each other, starting with n, then times by n minus 1, 1 less than n. So they're the kind of patterns, if you can try to get those spotted in your brain, then you'll be able to see how this formula develops quite easily. Okay, the next one is going to be, we've got x to the power 1, x to the power 2. So it's going to be x to the power 3. But the question is, what comes before it? And you'll notice I've left quite a big space this time. So that's because on the fraction it's going to be quite a lot. So let's see if you can guess what the bottom of the fraction is going to be. Just type it into the chat window if you can guess. So that one is 1, really 1 factorial. This is 2 factorial, which means 2 times 1. So the bottom of this is going to be close on the top. We'll come to the top in a second. That's the tricky bit. Good. 3 factorial on the bottom. That's good. That's a nice easy start. So on the top, we're going to have 3 numbers. So you're right, we're going to have 3 things being multiplied by each other. But each, as we go along, it's going to go down by 1 more. So we're going to have n, like we had here at the beginning, times by n minus 1, like we had here on the second x squared term. And then I need something else. I need a third term here, a third bracket. So I had x to the power 2, and I had 2 things at the top. So x to the power 3, natural to think that I've got 3 things at the top. And they just have to remember that it goes down by 1. So it's going to be n, not minus 1 this time, but minus 2. Good. So that's the general formula that we're going to use to expand anything like minus 5. We don't need to keep going on because you should get the pattern by now. In terms of the x, it's going to be, let me just rub that bit out. So you should get the pattern by now. Have a quick look at the pattern again if you're waiting for me. So firstly, we start with 1. That's coming from this one. And then the powers of x start with x to the power 1, x to the power 2, x to the power 3. You could even say here there's an x to the power 0 if you want. But just stick to x to the 1, then x to the 2, x to the 3. And then how do we develop the fraction? The first one is just n. Then the next one is n bracket n minus 1. The next one is n bracket n minus 1, n minus 2. So you think if there was an x to the power 4 term, which I'm not going to write, but just think, what would it have at the top? Wouldn't it have n, then n minus 1, then n minus 2, and then, because you need a fourth thing, it's going to have n minus 3. And then on the bottom, have a look, you got 1, 2 factorial, 3 factorial, then 4 factorial. So just by knowing what the pattern is, you should be able to follow this formula for as much as you need. So let's use it. That's the formula, and we're trying to do 1 plus x to the power minus. Now I'm going to stick to the example in the question in the textbook. So let's go with the example in the textbook is 1 over 1 plus x. So it looks like quite an easy example, but slight problem is that it needs to be written in this exact form. We don't want the 1 plus x at the bottom of a fraction. We don't want any fraction at all. So you have to remember from year 1, how are you going to rearrange this or rewrite this? 1 plus x is really 1 plus x to the power 1. And then I can bring it to the top of the fraction as long as I change the sign on that power. So 1 over 1 plus x to the power 1 is really 1 plus x to the power minus 1. So now I've got it in that form. That's the form I really want to use to then expand. Okay, so let's use that formula. If you want to do the first two bits, should be nice and easy for you. If you just want to type them in, what are you going to get first? Okay, no surprises for 1 coming first, then a plus, and then n. N is the power we have at the bracket here, so that power is -1. And then x to the power 1, so that's just x. So that's the second term done. And now let's move on to the next bit. So let me give you a few seconds to have a look at the next term along and try to think what's that going to be. So starting with the fraction, what am I going to have at the top? N is now -1, so I'm going to have -1 times by, this is n minus 1, so it's -1, take off 1, so that's -2. On the bottom is 2 factorial, which is 2 times 1. If you remember, it's just 2 times 1, which is 2. So that's the fraction done. And then what's the x power going to be? It's going to be x squared. Nothing tricky about that. Okay, we can simplify in the next step down, but I would just say take it easy. Just try and get the numbers in the right places to begin with. Don't try to get it all done in one go. Okay, so now on to the next term, and I'll give you a few seconds. You should be able to do the top of this fraction now. So it's n times n minus 1 times n minus 2. I just want to know what numbers should I put in each of these three spaces. Type it in as soon as you know. Okay, the answers from before are good. But now here comes the first tricky one. So good, -1 times -2 times -3. You're taking that power of -1 and then you're reducing it by 1 each number along. Fantastic, mashallah, good. Okay, and on the bottom it's 3 factorial, which is 3 times 2 times 1, which is 6, so I might as well write 6. Actually, it's better to write it out 3 times 2 times 1, and you'll see in a second why. Times 1 we don't really need. Okay, good. And then just the last bit is the x cubed, which is just x cubed. Nothing tricky about that. Okay, not sure in the textbook how many terms we want, so let me just quickly check what it's saying. Find the first 4 terms. So that's fine. We've got the first 4 terms. We've got the 1 is the first term, then 2, 3, 4. So that's good. So now we need to simplify and really turn it into something that's more readable. So the reason that I said don't get the actual answers on the top and the bottom is because we can get a lot of it to cancel out. So the 1 is just 1. Then comes -1 times x, which is -1x. And I can just write that as -x. Good. But now watch what happens here. Anything on the top can be cancelled with anything on the bottom. So the -2, just the 2, can be cancelled with the 2 here. So I'm just left with -1 times -1, which is just 1. So that whole fraction becomes just 1, and I've got x squared. So 1 plus 1 x squared. And again, I don't really need that 1. You take a look at the last fraction. What can you cancel on the top and the bottom? You got the 3 here, that can cancel with the 3 here. You'll have a minus still. The 2 can cancel with the 2 here. So really, remember, when you're cancelling, it just means that you're ending up with 1. So it's not like there's nothing there, but it's just 1, which when you divide by 1 or times by 1, it doesn't really change anything, so you don't even need to write it. So what do you have? You've got -1 times a minus times a minus. Well, that's just minus 1. So you're going to have minus 1x cubed. And again, I don't need to write there 1. So I can just write that as minus x cubed. Okay, a plus and a minus, that makes a minus. So I can write over that. And that's your final answer, 1 minus x plus x squared minus x cubed. Okay, join me tomorrow for more binomial expansion. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.